Okay. So, hi everyone. So, good afternoon all. So, first of all, let me know whether audio and video everything clear. Yes. Hello Kumar, good afternoon dear. Okay. So, let me know whether audio and video clear here. So, if it is not clear, please comment it in chat box. Okay. Okay. So, we are dealing with what? We are dealing with the subject electromagnetics. Electromagnetics, and we are dealing with the topic electrostatic potential energy and electrostatic potential, right? Okay. So in the previous session we have determined the potential due to a sphere, yes or no? So that means if the charge is distributed uniformly on the surface of the sphere, if the charge is distributed uniformly on the surface of the sphere of radius capital R, So in this case we try to determine the potential in all the regions. So what we got here, for R greater than capital R we have determined, and for R less than capital R we have determined, and for R equal to capital R we have determined. So what we got for R greater than capital R, we got electric field E is equal to Q by 4 pi epsilon into R, AR cap. Now for this one, for R less than capital R, we got E is equal to Q by 4 pi epsilon capital R, AR cap. For R equal to capital R, we got E is equal to Q by 4 pi epsilon capital R, AR cap. So we have seen that the potential on the surface of the sphere and the potential, sorry, it is potential, no, sorry, it is potential, na? So V, so here V, here it is nothing but V. So the potential at R for R greater than capital R, so this is potential at R for R less than capital R, so this is potential at R for R equal to capital R. So you can simply write here V capital R. Understood? Okay. So even though the electric field inside this sphere is equal to 0, we got what here? We got the potential as what? We got the potential as Q by 4 pi epsilon capital R. Yes or no? Okay. So whatever the potential that you are having on the surface of the sphere, the same potential will be maintained inside the sphere also. So we got the graph here. We have drawn the graph also. So the graph, how we got here? The graph for this one. So this is for R equal to capital R, R less than capital R. This is for R greater than capital R, and this is for R less than capital R, right? So this is the potential along R. So the potential inside the sphere is same as what? Is same as the potential on the surface of the sphere. So after that what will happen here? The potential is going to decay. So it is going to decay as V is inversely proportional to R. Understood? So this is the graph we got here. Now next we have seen if the charge is distributed, throughout the volume of the sphere here, if the charge is distributed throughout the volume of the sphere. Okay, if charge is distributed throughout the volume of the sphere of radius capital R. Understood? So here we have considered the charge density as rho v, right? So for this one here, what are the potentials we got here? So potential for R greater than capital R and the potential for R less than capital R. The potential for R less than capital R, and then potential for R equal to capital R. So what we got? Expressions. So the potential at R, what we got here? Rho v, what we got? So for R less than capital R, we got VR is equal to rho v by 3 epsilon into 3r square minus small r square divided by 2. So this is what we got, right? Okay, so for r equal to capital R, we got rho v. For r equal to capital R, we got rho v capital R square divided by what? Divided by 3 epsilon, right? Okay. Next, outside the sphere, what is the expression we got here? What is the expression we got? So that is E equal to rho v r cube by 3 epsilon r square. So we got, I think we got rho v r cube by 3 epsilon r. I hope this is the potential we got. Is all the expressions correct here? Whatever I have written, all the expressions are correct. Please check here. We have already derived all these things in the previous session, right? So Alok Kumar, please check whether all the potentials that I have written are correct or wrong. All are correct now? Yes? Okay. So I hope all the expressions are correct, right? So for this one here, for this one, if we draw the graph, we have drawn the graph. So R, here this is potential. So here we have considered R equal to capital R. So this region is R less than capital R and this region is R greater than capital R, right? Okay. So now here we have seen that the potential at the center, that is at R equal to 0. So the potential at the center is maximum, yes or no? So the potential at the center will be maximum. So then it is going to decrease. It is going to decrease like this, right? Next, at R equal to capital R, So at R equal to capital R, the potential is nothing but rho v capital R square by 3 epsilon, and at R equal to 0, we got rho v R square divided by what? Divided by 2 epsilon. Understood? Okay. So this is at the center and this is on the surface. And also we have seen that the potential at the center is 1.5 times of what? 1.5 times of the potential on the surface. Yes or no? So all these things we have seen here, right? Okay. So all these things we have seen, right? Okay. So now today we'll try to solve some more problems, some more different types of problems based on this potential. See, if you understand the basics, that is basics of vectors and then coordinate systems and then vector operations like a gradient, divergence and curl, okay? So and then electric field and then potential. So these are the very, very basic concepts that are needed here, okay? So if you are very strong in these basic concepts, then you can understand any topic in electrostatics and magnetostatics also, right? Okay. So I hope you have understood each and everything up till now, okay. So now we try to solve some problems here. Right? See here, we know the relation here. We know the relation between the potential and electric field. Yes or no? So what is the relation between potential and electric field here? We know that V is VAB. If you want to determine the potential difference between A and B, VAB is equal to what? Integral A to B E bar dot what? E bar dot DL bar, or you can write this as minus of integral B to A E bar dot DL bar. Understood? In this manner you can represent. Next, we know this relation also. E bar is equal to what? E bar is equal to minus gradient of V. E bar is equal to minus gradient of V. If suppose V is a function of only one variable here, if V is a function of only one variable, let us say V is a function of X, then E bar will become what? Then E bar will become simply minus dou V by dou X Ax cap. Right? So that means the relation between electric field and the potential is simply E is equal to minus dou V by dou X. Understood? So if V is a function of only one variable, that's what I am considering here. Okay, so if we assume V as a function of what? As a function of only x. So then in that case I can write E bar is equal to minus dou V by dou x Ax cap, or E equal to minus dou V by dou x. Or if V is a function of both x and y, then you are going to get what? Minus dou V by dou x and then minus dou V by dou y Ay cap. Understood? Okay, if it is a function of x, y and z, then you are going to get all the x component, y component and z component. So if it is only one variable, then you are going to get the relation between electric field and potential in this manner. Understood? Okay, so if you differentiate the potential here, then you are going to get the electric field. So after differentiation, what you have to do? You have to multiply with what? You have to multiply with minus. Then you are going to get what? Then you are going to get electric field. Now similarly, if you want to determine the electric field here, if you want to suppose if they have given electric field, then in that case how to determine the potential? So if you know electric field, then we can determine the potential by using this relation, and if you know potential, then you can determine the electric field with this relation. Understood? Okay, so whatever you want you can use here. Okay, so these are the relations between electric field and potential. That's what you have to understood, right? So if you differentiate the potential function, you are going to get electric field. If you integrate the electric field function, you are going to get the potential. Okay, so remember these things here, right? Okay. Rahul Thakur, how to memorize formula, sir? See, if I would have given you directly the formula, so without deriving it, without explaining it, if I would have given to you directly the formula, then it would be very difficult to remember. Understood? Okay, but what we have done here, we have followed each and every step. We know how we got that formula. Understood? Okay, so if you practice that derivation and if you try to solve some problems, okay, so then that formula will be automatically fixed into your mind here. So it all comes with the practice here. Okay, so it won't happen overnight, right? Okay, so you have to practice again and again. So you have to practice however we have derived, the same thing you have to practice again and again, and based on this you try to solve some more problems. Understood? Okay, so then automatically that formula will get fixed into your mind. There is no need to by heart all those things, right? Okay, so I have explained how we have derived all those things, right? Okay, so it's a step-by-step process here, so it will come slowly, right? Okay, so we try to solve some problems based on this, right? Okay, so now here, see here, they have given the graph here. So that means they have given here something missing. Okay, wait. Wait here. So something is missing here. Okay. Wait here, wait. Okay. Okay, yeah. So this is the graph they have given here. This is the graph they have given. Okay. So they have given the graph between the potential and x here, potential versus x. That means they have given how the potential is varying with respect to x. So that means they have given v of x. They have given v of x, and they are asking to determine what? They are asking to determine the electric field. They are asking to determine the electric field, right? So Manikanta Kumar, good evening. Good evening, dear. Good evening. Okay. So they have given the potential function and they are asking to determine the electric field here, right? Okay. Okay. So now how to determine the electric field? So we know that just now we have seen that electric field E is equal to what? E is equal to, so since V is a function of only x, V is a function of only x, so you can write it as E is equal to what? E is equal to minus dou V by what? Dou V by dou x. Understood? Okay. So the differentiation of potential function is going to give you the electric field. Then you have to multiply with what? Then you have to multiply with minus sign. That's it. Understood? Okay. Okay. So now see here. So here from minus 3, okay. So if you observe this line here, okay, so the slope of this line is constant or not? See, dou V by dou x will represent what here? Dou V by dou x will represent the slope. Yes or no? Okay. So here the slope of this line here, from here to here, the slope of this line is constant or not? Yes or no? It is constant and it is positive. So here for this line, slope is what? Slope is positive. Slope is positive and constant. Slope is positive and constant. So that means dou V by dou x is going to be constant and positive. Understood? Okay. Next, for this line here, for this line, slope is what? Slope is negative. Slope is negative and constant. Slope is negative and constant. Understood? So that means dou V by dou x from here to here is going to be what? Is going to be constant and its value is going to be negative. Understood? Next, for this one, slope is what? Slope is 0. Slope is equal to 0. Understood? Next, for this one here, slope is what? Slope is positive. Slope is positive and constant. Yes or no? Now here dou V by dou x is nothing but what? Is nothing but slope. Right? Okay. Now you can determine the electric field value. Yes or no? It is very, very simple. Now see here, between the range from minus 3 to minus 2 here, between minus 3 and minus 2, what is the electric field? So when x is varying from minus 3 to what? Minus 3 to minus 2. So minus 3 to minus 2. So in this case, electric field E is equal to what? E is equal to minus of, we have to write simply the slope of this line, So what is the slope of this line here? So here it is 15 and here it is minus 10. Yes or no? Here it is minus 10 and here it is 15. So what is change in V? Is nothing but 15 minus of minus 10. So change in V is nothing but 15 minus of minus 10 divided by what? Divided by what is change in x here from here to here. Yes or no? The change in x from here to here, from minus 3 to minus 2. So what is the change? Change is nothing but what? What you are going to get? Minus 2 minus of minus 3. Yes or no? So that is minus 2 minus of minus 3. Right. So what you are going to get here? Electric field. So you will get here electric field E is equal to what? Minus of, so 15 plus 10, that is 25, divided by what? Divided by minus 2 plus 3, that is 1. So this is the electric field within the region what? Within the region minus 3 to minus 2. So next from minus 2 to plus 1 here, from minus 2 to plus 1, what is the electric field here? So from minus 2 to plus 1 here. So from x is varying from minus 2 to plus 1. So in this range, E is equal to what? E is equal to minus of. So you have to write dou v by dou x, that is nothing but slope. So the slope of this line is negative and constant. So what is the slope of this line here? Tell me, what is the slope of this line? What is the change in v? Change in v as you move from here to here. What is change in v? Is nothing but 5 minus of 5 minus 15. Yes or no? So change in v is nothing but 5 minus 15 divided by what? Divided by change in x, that is 1 minus of minus 2. Yes or no? 1 minus of minus 2. Right? So 1 minus of minus 2. So what you are going to get? E is equal to minus of 5 minus 15 is how much here? Minus 10 divided by what? Divided by 3. 10 divided by 3. So minus of minus will become plus. So you will get simply 10 divided by 3 volt per meter. So this is the electric field in which region? In which region here? So from x varying from minus 2 to what? Minus 2 to 1. Minus 2 to 1. Right? Okay. Next consider in this region here. So from 1 to 2. So x is varying from 1 to 2. So within 1 to 2, the slope is nothing but what? 0. So you can say directly slope is equal to 0. So within the range, x varying from where to where here? Tell me. X varying from 1 to 2. So if it is varying from 1 to 2, in this range, electric field is equal to what? Is equal to 0. 0 volt per meter. Because the slope is what? The slope is 0. Right? Okay. Next see here. So for this one here, the slope is what? The slope is positive and constant. So what is the slope here? Here the change in potential is how much here? Here it is 10 and here it is 5. So 10 minus 5 is 5 divided by what? Divided by change in x, that is 3 minus 2, that is 1. Okay. So 10 minus 5 divided by 3 minus 2. So that is 5 by 1. Right? Okay. So within the range 2 to 3. So the electric field, what we got here? Electric field is equal to minus of change in v by change in x, that is 10 minus 5 divided by 3 minus 2. 10 minus 5 is 5 divided by 3 minus 2, that is 5 by 1, that is minus 5 volt per meter. Minus 5 volt per meter. So this is the electric field. Right? Okay. So Rahul Thakur, if we write an equation of a straight line, from there we can also calculate or not? Yes, because but it is a somewhat lengthy process, no? Yes or no? So every time there is no need to write the line equation and all those things here. Okay. So just here what you want just only slope of the line, that's it. Right? Okay. So you want only slope of the line, and they have given the graph in this manner. So if you know the slope of each and every line, then you can determine the electric field within that range. Understood? Okay. Okay. Yeah. So these are the electric fields. See, mathematically you can have many methods here. Okay. But we try to follow the simplest method. Yes or no? Okay. So this is the electric field within the range minus 3 to minus 2, and this is the electric field 10 by 3 within the range minus 2 to 1, and within the range 1 to 2 the electric field is 0. So within the range 2 to 3 the electric field is what? Minus 5 volt per meter. Now if we try to draw the graph of electric field here, so what you are going to get? So let us say this is x and this is electric field. Right? Okay. So from minus 3 to, from where to where you want the graph? Minus 3 to plus 3. So that is minus 3 to plus 3. Minus 3 to plus 3. Right? Okay. Yeah. So from minus 3 to minus 2. From minus 3 to minus 2, the electric field is minus 25 volt per meter. So let us consider this is minus 25. Okay, minus 25. So at minus 3 the electric field, from minus 3 to minus 2 the electric field is The electric field is what? The electric field is at minus 25. Okay, so the electric field is minus 25 volt per meter. Right. Next, minus 2 to plus 1, minus 2 to plus 1. So from here to here. Minus 2 to plus 1, the electric field is 10 by 3 volt per meter. So let us say this is 10 by 3. Let us say this is 10 by 3. Okay. So from minus 2 to plus 1, it will be, it is 10 by 3. Okay. So here this value is 10 by 3, 10 by 3. Next, 1 to 2, electric field is 0. So between 1 to 2, between 1 to 2, the electric field is 0. The electric field is 0 between 1 to 2. Next, 2 to 3, the electric field is minus 5. So 2 to 3, the electric field is minus 5. So let us say this is minus 5. Okay. So from 2 to 3, the electric field will be minus 5. Understood? Okay. So this is the graph of what? This is the graph of electric field. See here, if you observe here, exactly at minus 2 here, exactly at minus 2, the electric field is jumping from where to where? Minus 25 to what? Minus 25 to plus 10 by 3. So exactly at minus 2, exactly at minus 2, the electric field is jumping from minus 25 to what? Minus 25 to 10 by 3. So that means there is a discontinuity. There is a discontinuity at the location of what? At the location of minus 2. Understood? Okay. So there is a discontinuity of electric field exactly at the location of what? Exactly at the location of minus 2. Now similarly, whenever you are moving from, at exactly at 1 here, exactly at 1, what is happening? So here the electric field is 10 by 3, and from 10 by 3 it is decreasing to what? It is decreasing to 0. Okay. So from 10 by 3 to 0, it is suddenly decreasing at this location at 1. So that means here also there exists a discontinuity. Next, from 1 to 2, the electric field is what? The electric field is 0. Yes or no? The electric field is 0 from 1 to 2. Next, exactly at 2, what is happening? It is changing from 0 to what? 0 to minus 5. So there is a discontinuity here. Understood? So exactly at minus 2, you cannot say whether it is minus 25 or plus 10 by 3. So it is varying between what? Minus 25 and plus 10 by 3. So you cannot say the exact value of electric field at x equal to what? At x equal to minus 2. Similarly at x equal to 1. Similarly at x equal to 2. So exactly at these locations, the electric field is jumping from one value to what? From one value to another value. So you cannot say the exact value of electric field at these locations. So there is a discontinuity at minus 2 and plus 1 and plus 2. Understood? Okay. 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 Rahul Thakur. Okay, here we will see all the methods. Why you are so much excited? Okay, we will see all the methods. I will tell you how to write the equations and all. Right? Okay. Okay. We are having just I have started with the first problem. Now we are having many problems. We will do all those things. Right? Okay. Okay. I will tell you how to write the line equation and all those things. Right? Okay. Don't worry, first try to understand how we have solved this problem, right? Okay. Okay. Next same here. So they have given the potential function and they are asking to determine what? They are asking to determine the electric field. Okay. So I hope you can solve this problem here. I hope you can do this problem, right? Okay. So I am giving this problem as homework. I am giving this problem as homework, right? So I hope you can solve this problem. Here, see, here the slope is what? The slope is constant and positive. Here slope is 0. Here slope is negative and constant. And here slope is positive and constant. Understood? Okay. So we can easily guess how the electric field will look like. Here the slope is positive and constant. So E is equal to what? E is equal to minus dou V by dou X. Yes or no? So if the slope is positive means the electric field value is going to be negative. Understood? So I will just draw the rough diagram here. So you have to do it as homework. Okay. So up to here. So let us consider this is electric field, right? Okay. So just I am drawing the rough diagram here. Okay. Here slope is positive and constant. So the electric field is nothing but what? Minus of this slope. So that means you are going to get some negative value here. You are going to get some negative value. Next, the slope is 0. So from 2 to 6, the slope is what? The slope is 0. From 2 to 6, the slope is 0. So that means here it is going to be 0 from 2 to 6. Right. Next, from 6 to 10 here, from 6 to 10. So the slope is what? The slope is negative. Yes or no? The slope is negative and constant. So from 6 to 10 here, from 6 to 10. So from 6 to 10. From 6 to 10, the slope is negative and constant. That means electric field will be what? Electric field will be minus of this slope. So that means electric field is going to be positive. Yes or no? So you are going to get here in this region, you are going to get the electric field will be constant, something like this. Okay. Right. Next, again between 10 to 12 here, between 10 to 12. Between 10 to 12, the slope is what? Slope is positive and constant. So electric field must be what? Electric field must be constant and negative. Yes or no? So you have to get in this manner. Okay, so this is how you have to get what? You have to get the electric field. You have to get the electric field. Okay, so try to get the exact value of this field with the help of this graph, right? Okay, so I hope you can do this one, right? Okay. Next, so next problem here, next problem, see here. See here, now they have given the electric field here. They have given the graph of what? They have given the graph of electric field, and they are asking to determine the potential difference between what? Between A and D. So here the point A is this one and this is point D. So they are asking to determine what? They are asking to determine the potential difference between A and D. So that is, they are asking to determine VA minus what? VA minus VD. So this is what they are asking to determine. Right. Now, whenever they have given the electric field function and they are asking to determine the potential, then what you have to do here? So we know that VAD is equal to what? VAD is equal to what? Is equal to integral A to D. Integral A to D E bar dot what? E bar dot. Now here it is varying along X here. So that means the electric field is varying along X. So it is a function of only one variable. So I can directly write here. I can directly write simply E into what? E into dx. I can directly write simply E into dx. So VAD is equal to what? Integral A to D E into dx. Right. Okay. So in this manner I can write. Now see here. See, integration is nothing but what here? Integration is nothing but area under the curve. Yes or no? So you have to determine the area under the curve here. That's it. Understood? Okay. So how I can determine the area under the curve? Now see here. Whenever I am asking the potential difference between A and D, that is equal to integral A to D E dx. So this one I can write it as what? This one I can write it as, see here, From here to here, from A to this point, the electric field is constant, yes or no? So I am considering this point as B, and from B to C, let us say this point is C. Okay, so from B to C, the electric field is varying in this manner, and then again from C to D, the electric field is varying in this manner. Understood? Okay, so the electric field is varying from A to B, which is constant, and then from B to C, so it is just like a straight line, yes or no, with a negative slope, and from C to D, it is just like a straight line with a positive slope, right? So now how to determine VAD here? So integral A to D E dx. So this one I can write it as what? Integral A to B E dx plus what? Plus integral B to C E dx plus what? Integral C to D E dx. Okay, so in this manner here, I can determine what? I can determine the potential difference between what? Between A and D. If suppose for the same problem, if suppose they have asked to determine VDA here. If suppose they have asked to determine VDA. Okay, so what do you mean by VDA here? VDA is nothing but what? VD minus what? VD minus VA, which is equal to what? Which is equal to minus of what? Minus of VAD, which is equal to minus of VAD. Yes or no here? Okay, so if they ask VDA, then you have to write it as what? Minus of VAD. So VDA is negative of what? Negative of VAD. So remember all these things here. Remember all these things, right? Okay. 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 See here. So this one here, this expression, the same thing, I can write it as what? I can write it as minus of what? Minus of integral okay. So see, okay, so minus of integral D to A E dx, yes or no? So that is nothing but minus yes, so this is VAD, right? Okay, so VAD is equal to what? Is equal to, this is nothing but what? This is nothing but minus VDA. Okay, so VDA you can write it as minus VAD. Okay, so I hope you have understood this one, right? Okay. 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 So now see here. So whenever I will tell you a trick here how to calculate this one. See here. So I will tell you a simple trick. So y means if you calculate the area here, you know integration represents the area under the curve, yes or no? That you know. But here you have to determine, whenever they are asked to determine the potential difference between one point to another point, you must be specific that whether you are getting that surface area, whether you are getting the area under the curve is positive or negative, that you cannot determine, yes or no? So for that I am going to tell you a trick. Understood? So what is that here is, see here. So now here see, so first here I can divide this here, I can divide this into different regions. See here, so this one I can consider a region, yes or no? So this forms what? This forms a rectangle, yes or no? So I can determine this surface area, right? So let us say this surface area is A1, right? Next this will form what? This will form a triangular surface. So this surface area I am calling it as A2, right? Next this will form what? This will form another surface area. This will form another area. So let us say this is A3 here. Let us say this is A3. Let us say this is A3. So next you have to determine the surface area, the area under this curve. Okay, so this is A4. Let us say this is A4. Understood? Okay. Okay, yeah. So whenever they are asked to determine the potential difference between A to D, so what you will do is you just move from A to D here. So as you move from A to D, try to determine the area under the curve. Understood? So you have to move from A to D and try to determine the area. Now as you move from A to D, that means from left to right. You are moving from left to right. So as you are moving from left to right, I am considering this section here. I am considering this rectangular section. So what is the area of this one here? What is the area of this one? So is nothing but what? The change in X. And here, let us say here I have not given wait. So here take 5 and here consider here this is minus 10 here. This is minus 10, right? Okay. So now what is the area of this one here? What you have to do here is change in X into what? Into change in this field. So what is the change in X here? Is nothing but what? From here to here. The change in X is nothing but what? 1 minus 0. So you are moving from A to D, remember that. Okay, so whenever you are moving from A to D, so first consider this area. So here the change in X is nothing but 1 minus 0 into what? Into the change in this length here, the change in this length. So that is nothing but what? That is nothing but 5 minus 0. So 5 minus 0. Understood? Okay. So this is A1, plus now you have to determine area A2. So area A2 is like this here. Yes or no? You are having area A2 like this. So this is area A2. So here you are having 1 and here you don't know here. You don't know this point. Yes or no? And this is what? This is 5. This is 5. So area A2, if you want to determine A2, so A2 is equal to what? The area of this rectangle, that is half into base. So whenever you are calculating base, you are moving from left to right. So you have to take the change along base here. So that means you are moving left to right means you have to subtract this value. You have to subtract 1 from this value here. Understood? So you have to write here change in X, right? And half into base into height is nothing but what? Height is nothing but 5. So now you have to determine this point. You have to determine this point in order to determine this change in X. Yes or no? How you can determine this point here? So in order to determine this point, what I am going to do here is, so I'll try to write the expression for this equation of line here. I'll try to write the expression for the equation of this line. So what is the equation of this line here? How I can write? Tell me. See, this is nothing but what? This is just like y is equal to what? Y is equal to mx plus c. This is just like y is equal to mx plus c. Understood? Okay. Now m represents what? M represents the slope of this line. So what is the slope of this line here? What is the slope of this line? Tell me. So the slope of this line is equal to what? Is equal to minus 10 minus of 5. Yes or no? Minus 10 minus 5, that is minus 15 divided by what? Minus 15 divided by okay, so minus 15 here, minus 15 from here to here, the change is nothing but minus 10 minus 5, that is minus 15 divided by what? Divided by, here it is 1 and here it is 2, so that is 2 minus 1. So minus 15 by 2 minus 1. So this is the slope into X plus C, right? Okay, so what we got here? We got minus 15 by 2 minus 1 is 1, so minus 15x plus C. So this is the equation of the line we got. This is the equation of the line we got. Okay, now we want the value at this location here. We want the value at this location. So at this location, so we want the value at this location, right? Okay, okay here. So what I will do here is see here. So in order to determine the value at this location, I want to determine what? I want to determine this constant value C, right? Okay, so what I will do here is, So actually this is nothing but electric field here, yes or no? E is equal to, you can write minus 15x plus C, right? Okay, so this is E equal to minus 15x plus C. Now see here, at this point here, at this point, that means at x equal to 1, at x equal to 1, this electric field value is equal to what? Electric field value is equal to 5. So I'm going to write that one here. So at x equal to 1, at x equal to 1, electric field value is going to be 5. So that is 5 is equal to what? Minus 15 plus C. So from here, C value is equal to what here? C value is equal to, you are going to get 20. Yes or no? So that means I can write this equation of the line as what here? E is equal to what? E is equal to minus 15x plus what? Plus 20. So this is the equation of the line here. Yes or no? So E is equal to minus 15x plus 20. So this is the equation of this line. Understood? Okay? Okay. Yeah. So now, now at this location here, at this location, electric field is equal to what? Electric field is equal to 0. At this location, electric field is equal to 0. Now substitute here, in place of electric field E, substitute here 0, then you are going to get this x value. Yes or no? So if you substitute E is equal to 0, so then you are going to get minus 15x plus 20. So that is x is equal to what? X is equal to what you will get here? 15 divided by what? Sorry, not 15. You will get 20 divided by what? 20 divided by 15. So that is 4 by 3. That is 4 by 3. So that means at this location, the value of x is nothing but what? Is nothing but 4 by 3. Understood? Now you can write the area A2. So area A2 is equal to what? 1 by 2 into change in x. Whenever you are calculating change in x, you are moving from left to right. Yes or no? Remember that. So 4 by 3 minus 1 here. This is the base. So 4 by 3 minus 1 into what? Into height. That is 5. Okay. So what you are going to get here? What you are going to get? So 1 by 2, 4 by 3 minus 1 is 1 by 3 into 5. Yes or no? Okay. 1 by 3 into 5. Yes. So you are going to get 5 by 6 here. Right. Okay. So A2 is equal to 5 by 6 here. A2 is equal to 5 by 6. So this point is 4 by 3 we got. Okay. Okay. So here we got 5 by 6 area A2. So this is area A1 and this is area A2. Next, what is this area here? What is this area A3? So the half into base into height here. So what is this area? Tell me. So half into what is base here? The change in base is nothing but what? 2 minus 4 by 3. So that is 2 minus 4 by 3 base into height. So what is this height here? What is this height of this triangle? Tell me. So the height is nothing but 10. Yes or no? From here to here it is 10. So into 10. So this is nothing but what? This is nothing but area A3 plus you have to consider this area A4. So this is also a triangle. Yes or no? So that is half into what? Half into base. So what is the change in base from here to here? That is 4 minus 2. So 4 minus 2 is how much here? 2. Into height. Height is nothing but what? Height is nothing but 10. Same. That is 10. Okay. Okay. So that is VAD. VAD is equal to what? Here we will get 1 into 5. That is 5 plus 5 by 6 plus here here you will get 2 ones and here 2 5s. So here you will get 6 minus 4, that is 2 by 3 into 5. Yes or no? Plus here 2 will get cancelled. Here you will get 10. Right? Okay. Okay. So finally what you will get here? Tell me. Finally what is the answer you are going to get? Tell me. Tell me here. Do this simplification and tell me the answer. What you are going to get? So 5 plus 10 by 3 yes, okay. So tell me the answer here. 5 plus 5 by 6 plus 10 by 3 plus 10. So what you are going to get? What you are asking here? Rahul Thakur. Sir, what is the value of y-axis? See, along y-axis we have considered what? We have considered electric field. Yes or no? So along y-axis we have considered electric field, right? So E is equal to what? Generally this line equation is y equal to mx plus c. So y, in place of y, what you are having? You are having E. So E is equal to mx plus c. The slope of this line is nothing but minus 15. So minus 15x plus 20. So this is the equation of this line. Understood? Okay. Now if you want to determine this area A to here, if you want to determine, okay, so if you want to determine this area A2, then you need what? That is nothing but the area A2 is nothing but half into base into height, half into base into height. Yes or no? So in order to determine this base length, you need what? You need this point, okay. So I have told how to determine this point here. So we know this equation, yes or no? E equal to minus 15x plus 20. Understood? So along this line, exactly at this location here, we have taken, at what location here? We have taken at x equal to 1. Yes or no? At x equal to 1, what is the electric field you are having? You are having 5. Yes or no? So at x equal to 1, we are having electric field is equal to 5. At x equal to 1, electric field is 5. So we have substituted that. 5 is equal to minus 15 at x equal to 1. Substitute x equal to 1 plus, what I am saying here, somewhere missing, no, wait, okay. So minus 15 plus what? Minus 15 plus c. So from here we have determined what? We have determined c value, that is 20. Yes or no? Okay. So we got minus 15x plus c. So from here we have determined c value, that is c is equal to 20. So once we know c value, then you can determine this x value here. So at this location, electric field is equal to 0. So we have substituted E is equal to 0 here. Yes or no? If we have substituted E equal to 0, then we got what? We got x value. We got x value as what? 4 by 3. Understood? Okay. Okay. So what is the answer you got here? Tell me. What is the answer we got? Tell me. Minus 0.82. How you are getting minus 0.82 here? So this is area A1 we have determined, and this is another area, that is A2, and this is another area A3, and this is another area A4. Yes or no? So we have determined all these areas or not? So what is the final answer you got? Tell me. So 19.1. Okay. So here you are having 5, and here it is 1, right? And here this point we have determined here, that is 4 by 3, and this is 2, right? Next. This is 4. This is 4. Okay, so this point is A, this point is A, and this point is D. So they are asking to determine the potential difference between A and D. So this area, what you got here, this is 5 into 1, that is 5, plus this area is nothing but what, half into base into height, so that is 4 by 3 minus 1, 4 by 3 minus 1 is 1 by 3 into height. So into height is how much here, height is 5, plus area A3 is half into base into height. So what is the base here? So base is nothing but 2 minus 4 by 3. So 2 minus 4 by 3. So that means you will get what, 2 by 3 or not? Yes or no? So 2 minus 4 by 3, 6 minus 4 by 3. So that is 2 by 3 you will get. So you will get 2 by 3 here. Next, area of A4, half into base into height. So height is how much here? This one I have given minus 10. Yes or no? So height is 10, plus area of A4, that is half into base, that is 4 minus 2, 2 into height, height is 10. Okay, so this is what we got, right? Yes. Okay, so what is the final answer? So yes, 5 plus 5 by 6 plus 10 by 3 plus 10. Okay, so the LCM of this one is 6. Okay, so what you will get, 30 plus 5 plus 3 2s, 2 10s, 20 plus 1 6 plus 60. Okay, you will get 30 plus 60, 90, 90 plus 20, 110, 115, 115 divided by 6, right? Okay, so something you will get 115 divided by 6. Is it correct here? Which one you are asking here? Why 10 minus 10? Which one? See, you have to consider height here. You have to consider the height, right? Yes or no? Height is always what? Height or distance is always what? Is always positive, right? Okay, okay. What you are saying, height is minus 10. Maybe. Okay, so I think somewhere we have done something wrong here. Okay, if you take minus 10, what you are getting, Rahul Thakur? If you are taking minus 10, what you are getting? Tell me. So A1, A2, A3. So if you take half a base, so here if you take minus 10, okay. Next half into base into height. So if you take minus 10 here, okay. So what you are getting here then? So you are getting 5 plus what? 5 by 6. And then here 2 will get cancelled, minus 10 by 3, and here 2 will get cancelled, minus 10. So here you will get if you take 6 LCM, okay, so you will get 30 plus 5, 3 2s minus 20 minus 20. So 35 minus 40. No, yeah. Okay. Okay. So somewhere we have done some mistake here. You can you just go through the calculations once. Okay. Okay. So if there is any mistake, I will correct it tomorrow here. Right. Okay. So next. Next. So Rahul Thakur, you are getting minus 7.5. If you take minus 10, you are getting minus 7.5. Okay. Yes. Okay. So here half into base means delta x multiplied by height means delta h, right? So this is how you have to follow. This is nothing but area, yes or no? So A2 you have to calculate in this manner, A3 also you have to calculate in the same manner, and A4 also you have to calculate in the same manner. And here while calculating these values, you are moving from where to where? From left to what? From left to right. You are moving from left to right. Right. Okay. Okay. Yeah. So here change in x. Change in x means you have to take 4 by 3 minus 1 here. So delta h here, that is change in height. So the change in height means you have to consider this 5 minus what? 5 minus 0. So you are going to get 5, right? Next A3, for this one you have to take half into the change in x. What is change in x here? So that is 2 minus 4 by 3 you have to consider, and change in height. Change in height is nothing but minus 10 minus 0. Yes or no? Minus 10 minus 0. So you have to consider minus 10, I think. Okay. So for A4 also you have to write half into base into height. So the change in base is nothing but 4 minus 2, and this change in height is nothing but what? Minus 10 minus 0. Okay. So I think delta h you will get minus 10 here. I think here for this one A3 you will get delta h is equal to minus 10, and A4 delta h is equal to what? Delta h is equal to minus 10. Okay. Okay. Yes. Okay. So you just correct this one here. I think delta h you have to get minus 10, right? So the change in height must be minus 10. Okay. Okay. So take change in height is equal to minus 10. Okay. So then solve the problem. Okay. So next one. So they have given the electric field distribution is given as shown in figure. So then determine VB minus VA. So that means now here they are asking what? They are asking VBA. They are asking VBA. So VBA is nothing but what? VBA is nothing but VB minus VA. So this is what you have to determine. So VBA is nothing but what? VBA is nothing but what? Minus of what? Minus of VAB. Minus of VAB. So that is equal to, I can write minus of what? VAB, I can write it as integral A to B E bar dot dl. Now here let us consider, let us take some axis here. Let us take some axis. So let us consider this is nothing but E of x, let us consider, and this axis let us consider it as what here? Let us consider this axis as x axis. So let us consider this axis here. Let us consider this axis as x-axis, and on this axis let us consider this is E of x. This is E of x, right? Okay. So they have given how the electric field is varying here. How the electric field is varying. So I have considered on this axis I am considering it as x. Then it is going to give you how the electric field is varying with respect to x. So I am considering on this axis I am representing what? I am representing E of x, right? Okay. Okay. So now tell me the answer for this one here. Tell me the answer for this one. So it is just simply what? It is just simply minus of integral a to b E dx, E dx. So this is what you have to determine. Okay. This is what you have to determine. Now tell me here what you are going to get. What you are going to get. So you have to determine the area under the curve as you move from A to B. You have to move from A to B, and you have to determine what? You have to determine the area under this curve. Okay, so what is the area under this curve here? See, it is just like what? It is just like a trapezoidal or not? Yes or no? See, if you are having a trapezoidal here, if you are having a trapezoidal like this, okay, so you can determine the area in two ways here. So you can split this into two surfaces. So here you will get what? Surface area of triangle, and this one is nothing but what? Area of some rectangle. Then you can add these two areas. So this is one method. This is one method. Understood? Next, otherwise you can directly use the formula here. You can directly use the formula. So what is the formula to determine what? To determine the area of what? Area of trapezoidal. So that is nothing but half into summation of parallel sides here. Summation of parallel sides into what? Into base. Okay, so this is the base. This is the base. So A here, and here they have given B. Okay, so from A to B they have given 5 micrometers. 5 micrometers. Understood? Okay. And here they have given this as 20 kilovolt per centimeter, and this one they have given as 40 kilovolt per centimeter. So summation of parallel sides means what is the this parallel side height is how much here? 20 kilovolt per centimeter, and this height is nothing but what? 40 kilovolt per centimeter. So 20 kilovolt per centimeter plus 40 kilovolt per centimeter multiplied by what? Multiplied by base. So remember here we are determining this is nothing but what? This is nothing but VAB. Yes or no? VAB. So you have to move. You are moving from A to B. Understood? So that means let us say this point here, this point is 0, 0, then this point will become what? This point will become 5 micrometer, 0, 5 micrometer, 0. Understood? Okay. So whenever you are writing base here, so here you have to always write the change in base, change in base. Understood? So what is the change here? Always how you have to take final minus initial. So you are moving from A to B. So what is the final value? Final is nothing but 5 micrometer, and initial is nothing but what? 0. Understood? So that's how you have to take here. Right? So you are going to get what? This is equal to 1 by 2 into summation of parallel sides, that is 20 kilovolt per centimeter plus 40 kilovolt per centimeter, that is how much here? 60 kilovolt per centimeter into base here. So the change in base as you move from A to B. So that is nothing but 5 minus 0. So that is 5 micrometer. 5 micrometer minus 0. Understood? Okay. So directly you can get the answer. Now that is equal to half into what? Half into 60. So kilovolt per centimeter, how you can write here in terms of volt per meter? See, kilovolt means I can write it as 10 power 3 volt per centimeter, means I can write 1 into 10 power minus 2. So that is equal to what? That is equal to 10 power 5 volt per meter. Understood? Okay. So 1 kilovolt per centimeter, 1 kilovolt per centimeter, you can write it as what? You can write it as 10 power 5 volt per meter. So here 1 into 10 power minus 2 meter here. Okay. So 60 into 10 to the power of 5 volt per meter into what? Into 5 into 10 power minus 6. 5 into 10 power minus 6 meters. Okay. So here meter, will get cancelled. Okay, so here 2 ones and here 2 30s. So you are going to get 30 into 5, that is 150, into 10 power 5 into 10 power minus 6, that is 10 power 5 into 10 power minus 6, that is 10 power minus 1. So you are going to get what? You are going to get 15 volt. You are going to get 15 volt. So this is what? This is VAB. This is VAB. Yes or no? We have determined VAB. But they are asking what? They are asking VBA. They are asking VBA. So VBA is equal to what here? VBA is equal to what? VBA is equal to VB minus VA, which is equal to what? Which is equal to minus of VAB. So that is equal to what here? That is equal to minus 15 volt. Okay? Okay. Is this one clear here? Tell me. Not millivolts here. You are getting minus 15 volts. Yes or no? Minus 15. It must be minus 15. Okay. See, in the same problem here, in the same problem, if they would have asked VA minus VB here, in the same problem, if they have asked VA minus VB, that is VAB, then the potential is going to be what? Then the potential is going to be plus 15 volts, plus 15 volts. Understood? Okay. So since they are asking VBA, we got what? That is nothing but minus of VAB, that is equal to minus 15 volts. Understood? Okay. 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 So today somewhat some mathematical mistakes have happened here. Sorry for that. Okay. So okay. But anyway, I hope you have understood the methods which I have followed, right? So I hope you have understood the methods which I have followed for this one, right? Okay. 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 See, if you want to determine, if suppose, see, for the same problem, okay, instead of determining VAB, you can, if you want to determine directly VBA, so that is, this is A and this is B. If you want to directly determine VBA here, okay, then you have to move from B to A. Then you have to move from B to A. Yes or no? So this point is 0, 0, and this is 5 micrometer, 0, and this is 20 kilovolt per centimeter, and this is 40 kilovolt per centimeter. Right? Okay. So if you want to determine VBA, then you have to move from B to what? From B to A. So whenever you are writing VBA, so that is equal to what? Integral B to A E dx. E dx. Yes or no? So that means from B to A, you have to determine the area under this curve. So you have to move from B to A. So whenever you are moving from B to A, how you have to consider here? So I have told that how to calculate the area of the trapezoidal. So that is half into what? Half into summation of what? Summation of parallel sides. So that is 20 plus 40. So it is going to remain same. That is 60 kilovolt per centimeter multiplied by the change in base here. The change in base. So here the change in base means you are moving from where to where? From B to A. So the change in base always you have to consider as what? Final value minus initial value. So what is the final value? As you move from B to A, the final value is going to be 0 and the initial value is going to be what? 5 micrometers. So here whenever you are writing change in base, what you have to write? 0 minus what? 0 minus 5 micrometer. 5 micrometer. So then you are going to get what? Then you are going to get the same result. Okay, so finally you are going to get minus 15 volts. Understood? So directly also you can determine in this manner. So that is the difference here. Okay, so it all depends upon whether you are moving from left to right or right to left. Understood? So if they ask the potential difference between A and B, that is VA minus VB, then go from right to left. If they ask the potential difference between B and A, you can do in two ways. One is what here? You can go from right to left, and determine the area, and then finally you can put minus, or you can directly move from B to A. Then whenever you are moving from B to A, you have to always represent here what? The change in base. Understood? The change in base is going to be negative here. So that's why you are going to get minus 15 volts. Right? Okay. Okay, yeah. So this problem is given in gate here. This problem is given in gate. See how simple it is. Yes or no? Okay. So this problem is given in gate. Okay. Gate for EC students, they have given this problem here. Right. See, only one step here. If you know the area of this trapezoidal, then the problem will be completed. Okay, just one thing you have to understand, that whether you are moving from A to B or B to A, what they are asking. Understood? So if they are asking VAB, if they are asking VAB, that is VA minus VB, then you have to move from A to B. Understood? While calculating the area. If they ask VBA, that is VB minus VA, then you have to move from B to A. Okay, so where comes the difference? So whenever you are writing this change in base here, the change in base, okay, here you are getting positive, whereas here you are getting what? Here you are getting negative. Okay, so that's the only difference here. So this is nothing but change in base, change in base length, change in base length, right? And this is nothing but what? Summation of parallel sides, summation of parallel sides. Okay. 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 So in this manner we can easily solve the problems. See, once you get familiar with the concepts, then it is very simple to do the mathematical calculations here. Yes or no? Okay. So so with this I am winding up the session for today. So tomorrow also exactly at 4 p.m. Tomorrow also exactly at 4 p.m. we are going to start the session. Okay. So tomorrow I will take some more different types of problems here, because this whenever we are solving the potential problems, the problems on potential and potential energy, okay, so you are automatically calculating electric field as well as potential, everything. Understood? So this topic is very, 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 very important here. So not only in the exam point of view, but also if you want to learn the subject clearly, you must have clear cut concepts on what do you mean by electric field, and what is Gauss law, what is this electrostatic potential and electrostatic potential energy. Okay, so if you understand these things very clearly, then you don't feel any tough while learning the further topics of the subject. Understood? So that's why I am spending this much of time on this electrostatic potential energy and electrostatic potential. Generally the students will get confusion whenever they are solving some problems based on this potential energy and potential. So they will confuse with minus signs and positive signs and all those things. Okay, so you must have crystal clarity, okay, while solving the problem, right? So they will give both the options here. You are going to have the answer in minus as well as what? Plus. So you have to take care of this minus and plus signs whenever you are solving the problem. Understood? Okay, so tomorrow we will see some more different types of problems here. See, up till now we have seen case 1. I have explained 2 cases, yes or no? So that is case 1 and another one I have told case 2, yes or no? Case 2. So in case 1 what I have told here, the net force acting on the object or the net force acting on the charge will be 0. In this case there will be no change in kinetic energy. In this case the overall work done or net work done in this case will be equal to 0, yes or no? So all these things I have explained. So in this case, how to determine the work done by the external agent and how to determine the work done by the field, and here in this case always the work done by the external agent is equal to what? Work done by the field. Yes or no? So all these things we have seen here. So this is case 1. Understood? In case 2, what is case 2 here? Here the net force here, the net force acting on the object is not equal to 0. So in this case, while solving the problems, what we have to apply here, we are going to apply law of conservation of what? Law of conservation of energy. Yes or no? So I have told what do you mean by law of conservation of energy. That is the total energy at any instant of time here, at any instant of time must be constant. So that is a differentiation of total energy with respect to time must be always equal to 0. So if we do that, we got that initial total energy, that is a potential energy initial plus kinetic energy initial is equal to what? Is equal to potential energy final plus kinetic energy final. Yes or no? So up till now, whatever the problems that we have solved is based on what? Is based on this case 1. Understood? Okay. So tomorrow also we try to solve 2 to 3 problems based on case 1. So then after that we will deal with the problems that will come under what? That will come under case 2. Okay. Okay. Yeah. So don't miss tomorrow's session here. Okay. So tomorrow the class will be exactly at 4 p.m. Right. So with this, I am winding up the session here. So tomorrow we'll meet exactly at 4 p.m. So until then, take care. Bye bye.